everyone. Thank you very much for signing in and watching my live stream. I'm Mr. Matt, and this is Dr. Tot. Dr. Tot, cookie? Cookie for class? Okay. And welcome to Algebra 2. This week and next, we're going to be devoting our normal time slot, not just our normal time slot, but Monday through Friday time slots to review the semester A in preparation for your final exam or midterm exams coming up. I want you to use these videos as well as the practice exam resources, namely Practice Exam 1 that I'm going to be releasing soon, as diagnostic tools for you to self-assess what areas you may need improvement in. That way you can identify them, go to the independent practice sets, as well as the quick drill sets A and B that I'll be putting out this week and next that will hone in on those specific areas for you to remediate your skills. Then I'm going to have two other practice exams, Practice Exams 2 and 3, for you to fine-tune your skills and really practice at a detailed level and a comprehensive on a comprehensive document right before your exam. If you have any questions, I'm always available in the comment section, as well as my social media platforms that are, or my social media accounts of the platforms that are linked in the description below. And if you have any recommendations on something that's really troubling you and that you can't find any resources for, please feel free to reach out. Let me go ahead and share my screen with you. And just a reminder, this is a live session, so there's a little bit of a delay with the iPad, but I'll try and mitigate that as much as possible. Today we're going to be looking at for the process of foiling, which is overarching throughout Algebra 2, so it's really a process that we need to make sure that you understand. And then also going back to the fundamentals and looking at some operations and equations with fractions. So this document is going to be posted on Certified Learning Center's website. The link will be in the description below, and just make sure that you're looking at the document that has a reference number of 2149-4 that I'm circling right there. If you got that, then you know that you're in the right place. Otherwise, let's go ahead and get right into it. So question number 1, I'd like you to FOIL the following binomials. So question 1a asks you to FOIL 2x plus 3 times the quantity 3x minus 1. Question 1b asks you to FOIL the binomials 3x minus 5 times the quantity 5x plus 2. So I'll give you 3 minutes. 1 minute in, I'll start to solve to give you some hints, and then we'll go through the entire question. Okay, so for number 1, if we're 1a, if we're foiling 2x plus 3 times the quantity 3x minus 1, first times first would be 2x times 3x. Outer times outer would be 2x times negative 1. Inner times inner would be 3 times 3x. And last times last would be 3 times negative 1. 2x times 3x is 6x squared. 2x times negative 1 is negative 2x. 3 times 3x is a positive 9x. And 3 times negative 1 is a negative 3. The negative 2x and the positive 9x can combine together to become a positive 7x, leaving you with a final answer of 6x squared plus 7x minus 3. For 1b, I mislabeled this, not 2a, it's 1b. For 1b, when we FOIL 3x minus 5 times 5x plus 2, first times first would be 3x times 5x. Outer times outer would be 3x times 2. Inner times inner would be negative 5 times 5x. And last times last would be negative 5 times 2. 3x times 5x is going to be 15x squared. 3x times 2 is going to be 6x. Negative 5 times 5x is a negative 25x. And negative 5 times 2 is negative 10. The 6x, the positive 6x, and the negative 25x will combine together to give you a negative 19x and a final answer of 15x squared minus 19x minus 10. If you have any questions, then please let me know. Otherwise, let's continue to number 2. So for number 2, I'd like you to FOIL the following binomials. 8x plus 1 times the quantity 3x plus 4. And 2b is 4x plus 4 times the quantity 6x minus 4. So I'll give you 3 minutes, and after 1 minute, I'll start to solve. Okay, so for number 2, when we FOIL 8x plus 1 times 3x plus 4, first times first is going to be 8x times 3x. Outer times outer is going to be 8x times 4. Inner times inner is going to be 1 times 3x. And last times last is going to be 1 times 4. 8x times 3x is 24x squared. 8x times 4 is 32x. 1 times 3x is 3x. And 1 times 4 is 4. The 32x and the 3x can combine together to become 35x, leaving you with a final answer of 24x squared plus 35 plus 4. For 2b, first times first is going to be 4x times 6x. Outer times outer is going to be 4x times negative 4. Inner times inner is going to be 4 times 6x. And last times last is going to be 4 times negative 4. 4x times 6x is 24x squared. 4x times negative 4 is negative 16x. 4 times 6x is a positive 24x. And 4 times negative 4 is a negative 16. The negative 16 and the negative 16x and the positive 24x can combine together to become a positive 8x, leaving you with a final answer of 24x squared plus 8x minus 16. If you have any questions, then please let me know. Otherwise, let's take a look at question number 3. So I'd like you to FOIL 2x minus 5 and 6x plus 3, as well as 4x plus 6 and 2x minus 4. I'll give you 3 minutes. After 1 minute, I'll start to solve. Okay, so for number 3, or 3a, first times first would be 2x times 6x. Outer times outer would be 2x times 3. Inner times inner would be negative 5 times 6x. And last times last would be negative 5 times 3. 2x times 6x is 12x squared. 2x times 3 is positive 6x. Negative 5 times 6x is a negative 30x. And a negative 5 times 3 is a negative 15. The positive 6x and the negative 30x will combine together to give you a negative 24x and a final answer of 12x squared minus 24x minus 15. 3b, first times first would be 4x times 2x. Outer times outer would be 4x times negative 4. Inner times inner would be 6 times 2x. And last times last would be 6 times negative 4. 4x times 2x is going to be 8x squared. 4x times negative 4 is going to be a negative 16x. 6 times 2x is going to be a positive, oops, excuse me, I added there. That should be a positive 12x. It's going to change our answer. And 6 times negative 4 is going to be a negative 24. Negative 16x plus a positive 12x is going to give us a negative 4x. And a final answer of 8x squared minus 4x minus 24. If you have any questions, then please let me know. Otherwise, let's move on to some work with fractions. So I would like you to calculate the value of the following fractions. We have 3/5 plus 6/7, and we have 8/9 minus 5/6. So I'll give you 3 minutes. After 1 minute, I'll start to solve. Remember that to add or subtract fractions, you need a common denominator. In order to multiply fractions, it's just straight across, numerator times numerator over denominator times denominator. And to divide fractions, you multiply by the reciprocal of the denominator. But 3 minutes, try your best, and then we'll go through these 2 problems. Okay, so for 4a, we have 3/5 plus 6/7. We don't have common denominators, so we need to manipulate these guys so we have common denominators so we can keep the denominator, add or subtract the numerator. The easiest way to find common denominators is to literally just multiply the numbers together. Notice that 5 and 7 have a product, or multiplied together, 5 times 7 is 35. So I know 35 is at least one number that they both share in common, or they're both divisors for. So if I do something to the denominator to change it into a new number, I have to do the same thing to the numerator, or else I violated a rule of mathematics. So as long as I multiply both numerator and denominator by the same value, I'm not changing the actual number. Notice that 7 divided by 7 or 5 divided by 5, both of those will reduce to 1. 1 times anything is that same something. So that's the overarching golden rule of mathematics. You can do anything, almost anything that you want to the left, as long as you do the same thing to the right. You can do almost anything that you want to the denominator as long as you do it to the numerator. So multiplying 3/5 times 7 over 7 and 6/7 by 5 over 5 will give me common denominators of 35. 7 times 3 is 21. 5 times 6 is 30. So this converts into 21 35ths plus 30 35ths. Once I have common denominators, I keep the denominator, add the numerators. So this is going to turn into 21 plus 30 over 35, which is going to be 51 over 35. For 4b, we have 8/9 minus 5/6. So again, I'm just going to multiply the denominators by each other. So I'm going to multiply 8/9 by 6 over 6, and I'm going to multiply 5/6 by 9 over 9. That's going to turn into 6 times 8 is 48. 6 times 9 is 54. So I'm going to have 48 54ths minus 5 times 9 is 45. So minus 45 54ths. I have common denominators of 54, so I keep the denominator, subtract the numerators. 48 minus 45 is 3. So we're going to have a final answer here of 3 54ths. If you have any questions, then please let me know. Otherwise, let's take a look at question number 5. I'll give you 3 minutes, and I'll start to solve after 1. Okay, so for 5a, we need common denominators between 5/3 and 5/6. So 3 goes into 6, 3 is a divisor of 6, and 6 therefore is a multiple of 3. So we only need to change one out of these two pairs of fractions. So the 5/3 I can take to a denominator of 6 by multiplying by 2 over 2. That second fraction of 1/5, I need common denominators between 1/5 and 3/10. So again, I can get common denominators by only changing one of the fractions because 5 is a factor of 10, or in other words, 10 is a multiple of 5. So I just need to manipulate that fraction of 1/5 to have a denominator of 10. I can do that by multiplying by 2 over 2. So that's going to end up giving me 10/6 minus 5/6 times 2/10 plus 3/10. Simplifying within the parentheses, 10/6 minus 5/6, keep the denominators, add or subtract the numerators. 10 minus 5 is 5, so I'm going to have 5/6 times 5/10. I can simplify 5/10 though because they're both divisible by 5. 5/10 turns into 1/2. So this is the same thing as 5/6 times 1/2, which is going to give us 5/12. For problem 5b, we had 4/5 divided by 2/3. So when we divide by fractions, when we divide a fraction by a fraction, it's the same thing as multiplying by the reciprocal. So keep the first fraction the same, keep 4/5 unchanged, but change the operation from division to multiplication, Then take the reciprocal of the second fraction. Reciprocal is a real complex, tricky word that just means flip the numerator and denominator around. So instead of 4/5 divided by 2/3, that's the same exact thing as 4/5 times 3/2. Multiplication is straightforward, it's just numerator times numerator over denominator times denominator. So 4 times 3 is 12, 5 times 2 is 10. 12/10 of both the numerator and denominator are both divisible by 2, so that will simplify into 6/5. If you have any questions, then please let me know. Otherwise, take a look at question number 6. We have 7/3 minus 1/6 times the quantity 3/4 plus 5/12. And 6b is asking, what's the value of 7/8 divided by 3/5, quantity minus 1/6? I'll give you 3 minutes, and after 1 minute, I'll start to solve. Okay, so for 6a, notice that to go from the denominator of 3 to a denominator of 6, I just need to multiply the first fraction of 7/3 by 2 over 2. The same thing is true for that other fraction of 3/4, except to go from 4 to 12, I need to multiply by 3, so I'll multiply that whole fraction by 3 over 3. 7/3 times 2 over 2 is going to give me 14/6. 14/6 minus 1/6 is 13/6. 9/12 plus 5/12 will give me 14/12. And then 13/6 times 14/12 will give me 182 over 72, which will simplify because both of them are divisible, both the numerator and denominator are divisible by 2, so that'll simplify into 91 over 36. For the second guy, 7/8 divided by 3/5, that's the same thing as 7/8 times 5/3. 7/8 times 5/3 is going to be 35 over 24. And now I need to get 1/6 to have a common denominator here, so I'm going to multiply 1/6 by 4 over 4. So this is going to turn into 35 over 24 minus 4 over 24. So that's going to be 35 minus 4 over 24, which is going to give me 31/24. If you have any questions, then please let me know. Otherwise, let's look at number 7, and this will probably bring us up to the end of class today. I'm going to give you 3 minutes. I'd like you to solve for the missing variable in the following equations. A hint, instead of going through all of the fraction operations, what you can do is you can multiply by a number that multiply by a multiple of all the denominators. That will eliminate the fractions and make the problem a lot easier to solve. Let me give you an example. I'm going to do A for you, or with you, and then I'll give you a few moments to do B. So for example, looking at 7a, we have denominators of 2, 6, and 8. So 2, 6, and 8 all are factors of 24. 24 is a number that that 2, 6, and 8 can all divide evenly into. So what I'm going to do, so let me first just copy this down, 1/6x minus 1/8x equal to 10. So if I take on both sides, now remember, if I do it to the left-hand side of the equation, then I have to do it to the right-hand side. But if I multiply on both sides by a common multiple of all the denominators, I'm going to simplify all of the fractions here into integer values. Remember that this 24 needs to go to all the numerators, not just one. So this is going to turn into 24 over 2x plus 24 over 6x minus 24 over 8x is equal to 240. But notice all of these will actually simplify into integers. 24 divided by 2 is 12, so that's going to be 12x. 24 divided by 6 is 4, so that'll turn into 4x. 24 divided by 8 is 3, so that'll turn into 3x. 12x plus 4x is 16x. 16x minus 3x is going to be a 13x. So x here is going to be equal to 240 divided by 13, which I don't think is going to be an integer number. No. So we're going to have about 18.46. So I'll give you 2 minutes. Please solve number 7b. Recognize that with the x in the numerator, that's the same exact thing as having the x alongside. So for example, x over 3, that's the same thing as 1/3 x. It's just that they're applying the x into the numerator. So I just wanted to point that out. I'll give you 2 minutes. Please complete 7b. Okay, so for 7b, if we look at the denominators, we have 3, 5, and 12. So the least common multiple between 3, 5, and 12 is going to be 60. So if I multiply both sides by 60, I'll be able to eliminate all of those complex denominators. So when I do that, I just need to make sure I distribute between all the numerators. So I get 60x over 3 plus 60x over 5 minus 60x over 12 is equal to 1200. 60x over 3 is 20x. 60x over 5 is 12x. 60x over 12 is 5x, or negative 60x over 12 is negative 5x. 20x plus 12x is 32x. 32x minus 5x is 27x. So we're going to get 27x is equal to 1200. Dividing by 27 on both sides, you're going to find that x here is going to be equal to about 44.4 bar. That means that decimal place of 0.4 keeps repeating over and over again. So it's 44.44444 repeating infinitely. Okay, if you have any questions on anything that we've done today, then please let me know either in the comment section below, or you can always get in contact with me on my social media accounts that are listed in the description. I hope that these videos are helpful. If you find them useful, then please subscribe, like, and share with your friends. But otherwise, I hope you all have a wonderful night. And Dr. Tot, do you want to say goodbye to everybody? It's the last class. Dr. Tot, come on. Come on, you gotta say goodbye. Come on. Come on. Come on, Tot. Come on. He's very hesitant. It's past his bedtime. Come on, let's say goodbye. Can you sit? Can you say bye? That's tongue. Bye. Okay, that's kind of good. All right. Well, thank you guys very much for watching. I hope you have a wonderful night, and I'll talk to you all tomorrow.